Okay.
So, okay, Alex, let's go. Let's do the fake laugh now, you know?
Okay.
That's
I
so
don't
bad.
know.
That doesn't work.
Welcome to the podcast for product engineers.
But yeah, Alex,
Yes.
so let's start talking about the topic today.
Yeah, for sure.
So we're talking about serverless architecture, right?
Exactly.
When did you start with serverless?
Yeah, I actually started with serverless like 6 years ago. Probably when I wanted to do something simple without actually to set up a whole like container or monolithic application running all the time. And the simple task could be just, I don't know, hacked based on some HTTP request.
Probably
or
like
something.
a Lambda or something like that, AWS.
Yes, it was, I believe it was like a Lambda from AWS, yes.
Would have been
for sure.
2017 or so, right?
Yeah, yes, it was like, yeah, exactly.
You told me earlier it's the 10-year anniversary of
Yeah,
Lambda now?
last week, if I'm not in mistake. Yeah.
And we are recording in 2024 November.
24, so
Yeah.
yeah, exactly. And they celebrated like 10 years of Lambda.
That's crazy.
And yeah, that's crazy
Think
because
about it.
I mean, if we think if I started like 6 years ago, maybe I already started a bit late, like only after 4 years, right?
Well, I mean,
But that's probably okay because I mean nowadays the technology is like growing every day, every week, right?
Yeah, it's
every
nothing
year.
special. It's nothing special.
It's like a simple way to run code on the cloud, right?
True.
Without actually managing the services.
Yeah.
And maybe here we can probably start with
For sure.
what's actually serverless, right? We are talking here no servers, right? But it's actually not true because the code actually runs on the server, but we don't need to manage.
Never name something by what it's not, right? So
Exactly,
like
exactly.
NoSQL,
So
serverless.
We are just following the pattern here, right?
Exactly.
And it's for me serverless is just a simple way to execute code and to execute, to build, deploy codes into the cloud without managing any infrastructure. That's what is serverless for me. It's like about simplicity. That's
Correct.
actually my take. Simplicity.
Yeah.
And especially when I want to try something new or to do a simple task, I actually go to a serverless first, right? Then I will see if it actually fits the purpose, right? Because here, if you are talking about for short, medium processes, that's probably okay. But if I want to do something like a long-running process, probably is not the best fit. But
Okay. Well, here at epilot, right? Like, I think we take a slightly different approach, right? We actually pretty much say that we use serverless for everything.
For everything,
like, that's the standard default choice. Doesn't really matter what you're building, right? So like even if it's a long running process, and I would go a little bit beyond like just running code, right? Like, I mean, there's step functions, there's databases. We use Dynamo for most things at epilot. So I would kind of almost expand the definition of serverless as just anything where I don't have to think about the server, right? So that's like, to me, it's more about like functions as a service. I think is the bread and butter, the kind of core of all serverless for sure. That's how you connect the pieces. But to me, it's almost like all of the like things like Cognito, DynamoDB. These services are so freaking amazing because it allows me to just not think about how do I scale this, how do I run this. Like at epilot, not having any ops people is probably the biggest thing for me that convinced me that this is how we should do it.
Yes, exactly. I think it's about the productivity, right? We can actually focus on our core product without taking care about the infrastructure, right? And especially if we are using serverless computing in a single provider and the cloud provider. In our case, we are all in AWS, right? And AWS already provides like a lot of services that integrate really well with our serverless approach. Like we're mentioning, for authentication, authorization purpose, we can use Cognito. We can combine with an API gateway to expose some API endpoints, right? We use Dynamo for persistence, right? Asset storage, you have S3, right? And and actually here is the funny part because the Lambda itself, we mentioned like the function as a services. So the Lambda is actually one of Lambda is the product of the function as a services of the AWS, and it executes code in response to events. And these events could be HTTP requests, right? Could be just the event coming from the database. In this case, for example, a DynamoDB stream, right? So we have everything. We have everything with our cloud provider AWS that we can take use of it and take advantage of the simplicity.
The cloud is your platform, right?
Yes, exactly.
Yeah. You don't have to architect and build your own, way to build your application. We don't have to agree on a lot of things because we just say, look, use serverless, use AWS. It just simplifies the everyday work of a developer.
Yeah, you have here the catalog of the services, and you just need to know how to combine these pieces together, right? And
but not everything in AWS is serverless. Like, where would you draw the line actually? Because I think there are a lot of services that are like close to it. They're like more on the managed side. But like, what's the differentiator to you?
That's a good point. I mean, when we choose a service to combine with a Lambda, for example, we need to take care or to think about several aspects, right? I would say, let's give an example. So we have a Lambda and we want to actually establish a connection to the database, right? And the database is not actually serverless, and maybe it's not, and the Lambda can actually scale really fast, right? Because it automatically allocates resources. And when we don't have any instance running, it just spins a new one, right? But this could be a problem because every time that we run or spin up like a Lambda, we are establishing a connection to a database, right? So we need to think about, how many requests actually we can make to the database. Should we put like a connection pool on top of the database, or the services already provide that for us, to reuse connection? So
like a proxy sort of thing.
Exactly, a proxy. So we need to think about these kind of things, like what about retry mechanisms, right? Rate limiting. So these kind of things are really important when we actually are architecture something in the serverless computing approach.
I think in the example you use, what's interesting is that that's an example of combining like serverless architecture with non-serverless pieces, right? So if you're connecting to something like a relational database, maybe you're using RDS on AWS, right? That's a pretty common use case because like we as developers, we probably all learned SQL at some point, and then it's like the default go-to. Although at epilot, I think most teams prefer DynamoDB because it's like flexible, serverless out of the box. It's simple. I don't have to think about things like connection pooling. It's also, I mean, it's not infinitely scalable. Nothing is, but it's like
for our use cases.
For our use cases, it is basically infinitely scalable. I mean, we do run into sometimes some rate limiting and then so on, but it essentially, like, that's the thing that draws me to serverless most of the time. It's just like the simplicity of I just pick something off the shelf. I don't have to think about, okay, what's the memory size I need? How should this react to different patterns of traffic or users, or like this specific use case? How should I scale it, or which type of resources should I run this on? It's just like, I deploy my code, I set up my data model, and that's kind of it. This to me is incredible productivity as a developer.
Yeah, exactly. And it's funny that we are now talking about actually how we architect serverless, right? And the aspects that we need to consider. And now the point is actually what's the role of the architecture in the serverless, and that's basically what we are talking.
You still have to do architecture even if you're serverless.
Exactly. if you exactly. So the Lambda itself, it's scalable, but in the whole system, is this Lambda? So a Lambda being scalable doesn't mean that the whole system is scalable, right? We have a lot of configurations and parameters that we need to know that exist, and we need to control. And as we already mentioned, like retry mechanism, right? And if we are connecting with some external systems, external services, we need to double check if they have some rate limitings, if we are actually reaching some bottlenecks in the service, There are a lot of things that we need to consider when putting all the pieces or the Lambdas together, right? And putting also the right services in the middle, right? And you already mentioned, we run code based on response to events. So probably here we can take advantage of event-driven architectures. Maybe it makes sense, right?
Yeah.
We can take advantage of some messaging queues like SKS or event reach, right? I think, we have, as we mentioned, we have a lot of services that can combine really well with the serverless architecture.
Right.
But it plays like crucial role, the architecture in serverless, because this is how we can actually maximize the benefits of these type of architecture, right? How we can optimize the scalability, the performance, right? This is important, not only in the serverless, of course, but everywhere.
Right, and I think it's part of the almost the definition of serverless is you end up in an event-driven way of building and an event-driven architecture, just because like your code only runs when something happens. And I love the fact that like that's usually like a business event. It's not like something on the operating system happened and that's now you have to run some code, but it's rather you're really thinking about, okay, the user clicked here on my application, or maybe I have to run a report at a scheduled time somewhere in the background, and that's when the code runs. And at that point you kind of have to start thinking about things like replayability. You have to think about, okay, how do I make this easy to retry if something went wrong. And like just having that access and being able to see that as a developer, looking at, let's say, step functions are, I think, a great example of this, where you actually have like a visualization of how the logic runs through an event. You get the event input, maybe you run some validation first on it, you throw the event away if it's not a valid event, but you can still retry, you can replay that stuff. And that creates this very, very like an architecture, an application that is very hard to fail, I would say, right? Like very, very resilient, because it enables you to kind of have full control of these events. And when you're building something very complex, like we are at epilot, which is a very, very broad, kind of very business-centric, we're vertical in the energy space, right? Most of what we do, it actually has very little to do with the technical and much more with kind of how the business logic should run. And in that kind of environment, it's so important things like calculations and how we process data works, and we're able to trace how those events flow through our system.
Exactly.
So I think that's one of the key, for me, one of the key draws of serverless is almost the fact that, like, as a developer, it's easier to understand sort of the interconnectivity. But that has a downside to it, right? Because like you end up connecting all these different pieces, all these different lambdas, all these different services. So like, how do you, Alex, how do you make sure that you don't end up in this super complex, monolithic, thing that just is hard to understand? How do you end up with not like a million lambdas that no one has any idea of how it works?
Yeah, for that's a really important point, and for that I think we have several tips that we can share for sure. One of them is, of course, try to decouple the services, right? Like group the services per domain, for example.
Sure.
Have a kind of microservices approach.
Or nano services.
Or nano services, exactly. That's, of course, one of the big points here. We also need to consider, of course, like the cold starts of a Lambda, for example. As we already mentioned, the AWS, our cloud provider, automatically allocate resources, even if we don't have a server instance available. And when we don't have, it's spin up one for us, but it takes time. And this latency is actually called like the cold start. And for that, for example, the dependencies that we have in our code are really important, right? Sure. For example, so we should actually try to optimize these kind of things. Exactly, performance. So in terms of performance, it's actually about the cold starts, and we should have a good monitoring. And in terms of observability, actually, it's quite important. And we should always take advantage, for example, of the CloudWatch. In our case, we combine the CloudWatch to Datadog, right? But using the logs and some metrics that we have for
distributed tracing.
Exactly, distributed tracing. Yeah. I think it's quite important to understand this kind of performance gaps.
And it's not just performance, right? It's actually just to understand also how things connect together. It's being able to trace, again, the event throughout all the different services and functions.
How we can combine timeout, right? Because a Lambda cannot run forever. So, we need also to do some calculations. Okay, this services has this timeout and the other has another, timeout. So we need actually to try to combine these kind of things like retry mechanism, as we already mentioned. So it's it's all about basically this communication of the systems that we need to act. But AWS actually provides some good documentation and command pattern, right?
Serverless Lens
from the well architecture framework, right? It's actually a great resource that we can learn and see the best practices.
Right, and we actually use this pretty heavily at epilot. Is we go through with our teams the architectures of our like actual products, and we go through the questionnaires of the well-architected tool that's available on AWS, and it helps us like think about, okay, did we do this right? Is there things that we should improve on security, on scalability, performance, all these things? So like it's nice to have like this established patterns from your platform directly. So like I would say that's super helpful. Yeah.
Yes, exactly. And for example, we are talking about the serverless lens, like a good documentation where we have the command perks, but AWS also has the serverlessland.com website where we can actually find some in diagrams and even in some GitHub codes, some common scenarios. And this is quite useful, right? I mean, we don't want to start from scratch all the time, right? So we should actually try to understand, based on the specific cloud provider, what are the best practices, right? That's all we can start, right?
With AWS, I think, because it's such a widely used, I think it's the biggest cloud platform for sure for serverless. I'm not sure for other things as well. But like, there's so much tooling out there, which is open source, which is official from AWS. We use, serverless application model, SAM. We use a lot of CDK constructs that are pretty high level, honestly. And we don't have to like always start anymore from the level of, okay, here's my Lambda and I have to configure everything from step by step. You actually get like pretty much the safe defaults, good defaults out of the box if you're using CDK constructs like Node.js function or Python function. And
exactly. I think we should leverage like infrastructure as a code as possible. And we have good tools out there, as you mentioned, right? That provide some boilerplate code and even in a structured way.
Default setups.
Exactly, default setup that we can start, right? And we can define our functions, our API gateways, wherever, other resources. And it's easy to deploy. And serverless, as you mentioned, we can run code easily on the cloud, but we should actually have a good experience when deploying this code. So in a matter of seconds, we can spin up, a Lambda integrated with a complex RESTful API, right? A matter of seconds, actually, right? And then we just need to iterate on it.
Absolutely. I'm a huge fan, by the way, of SST. Have you tried it yet?
I already tried for some simple projects, and the experience is awesome. They offer a great testability experience, right? I don't know if you already tried like the live Lambda.
Absolutely, love it. The debugging experience.
Exactly, debugging when we are locally. I think it's actually something that we should consider. How easy we can actually test and debug our functions locally, right? It's a really important point.
I think the craziest thing to me about this tooling is that like if I just want to build, if I just want to get something done, I want to be productive, I want to have a feature up by the end of the day. Not only can I do that, not only can I deploy with something like SST or SAM and just have the function running in AWS, but it will actually scale. Like I don't then need to like spend the next few months or figuring out, okay, like how do I then make this work if I actually get like more users for this? It's just gonna work in most cases, right? I mean, there are some, of course, edge cases. Maybe you did something wrong or you have to adjust some things, but in most cases, I just don't have to think about it. Like the code will keep running as long as it's there. So yeah, I'm a huge fan of this kind of
yes, exactly. Tooling. And the code keeps running. And it's also resilient, adaptable, right? And in order to actually achieve that part, it's important that we think about not only the system architecture, but actually the code architecture, right? Let's give maybe some example. At epilot, we usually use a common pattern, right? To build REST APIs is actually, we use a HTTP API gateway, right? That runs a single Lambda. That basically proxies the requests, and then internally in the code we actually route the request to the handler
validate
code, right?
The event,
exactly.
We request
of course, we have exactly. Of course, we validate the request, etc. But actually, we just route the request to the correct Lambda, right? But we need actually to have a good structure here, because we already mentioned that we use a lot of services that are available in the AWS, and it's easy to actually have spaghetti code in some cases, right? Not specifically at epilot, but in general, right?
We have some spaghetti code too, to be honest, right?
Yes,
I think you always end up with that, but you have to.
Yeah, at some point. But you actually try to, of course, iterate on it and fix. Yes, sure. Exactly. And for that, we need to consider code structure, right? And
how do you do that? What's your approach?
My approach.
Avoiding spaghetti.
Yeah. Recently, for complex services, for complex APIs, I use some solid patterns, more specifically the hexagonal architecture.
I like to call it onion architecture because that's how I heard it first.
Yes,
onion layers and all that stuff.
Yeah, exactly.
But
I call it hexagonal, but this is just a term, and actually it's quite useful because we can separate the core business,
the domain logic,
from the implementation. Domain logic we can separate this part from the implementation details of the infrastructure and also from the client requests. And we can imagine this. I imagine this not as an onion but a hexagon. But we can, for example, imagine that in the center of the hexagon we have the logic, and then the sides of the hexagon are actually the ports.
Right.
That we use to interact with the outside world via the adapters. And this we are following the direction from the logic, the core logic, to the outside world, but the ports can also actually act as a gateway as well from the client requests. And with this, we can actually, focus more in the core logic. Has the concept of serverless. It's funny, right? Because we can do like a relation with the serverless where we want to focus in logic. We don't want to actually be distracted by, or we don't care about the infrastructure. So this is kind of similar. I want to be able to actually develop, test my core logic without taking care of implementation details. I don't care if I'm using DynamoDB, for example.
Right.
I just have a port and I know the operations that I want to use, and that's it. Then I can have another team or another team member that can just focus on the implementation details of this adapter for the DynamoDB.
Or if you're on serverless, it actually ends up being that these adapters are kind of more your infrastructure in oftentimes. Like really, the function itself ends up being way more about the core logic than just to kind of set up and all of the surrounding pieces of your application. Because Lambdas, they kind of, because you already have the routing logic, like you said, on the API gateway level, you might have validation on that layer already. And if you're connecting to other pieces of architecture, like that ends up being more, you think about it more like infrastructure. And you mentioned testability with Lambda or functions as a service. That's one of the key things, is that I don't have to write test for every single piece, but you can actually test the whole function.
Absolutely.
This is super amazing. Like as a developer, again, like you're able to test the whole thing end to end. And because the function is kind of simple, it's input and output, you might have some effects calling some other services, but those are easy to test, right? So that's, I think, hexagonal architecture, onion architecture, what do you want to call it?
Yeah.
If you're using fast, it kind of becomes automatic to you.
Exactly, and we can also think the ports as our events, right? It's basically how we can access to the outside world that can be another Lambda or another services. This is actually, of course, something that we can relate, but for me, the key here is actually how we can basically abstract these implementation details from our core logic.
What do you think? I think there are two schools of thought for how do you design a good function? How do you design a good Lambda function? There's a school of thought that thinks it should be as small as possible. Of course, you want to keep that, but I think in reality, oftentimes you do end up with quite large code bases, quite large Lambdas in the end. Even if you don't run all of the code in kind of one Lambda execution, you might for example, in our case, we often have multi-purpose Lambdas, right? Which handle different types of events, right? Why? Because you want to share a lot of the code. Sometimes you don't want to have 8 different bundles, 8 different Lambda functions, but you might have one big Lambda that takes multiple different types of events, right? But what's your take on this? What's the best practice here? What do you think? And what if you end up with a larger Lambda? How do you deal with that?
With a large Lambda? First of all, I think if we have multiple Lambdas and we want to manage we manage them in a good way, probably we should think about, first of all, a monorepo, for example, structure, where we have all the pieces together, even that we are actually deploying the code through like really simple lambdas focusing on a specific tasks. At least we have everything together.
You can share code with
the
different lambdas.
Exactly, between lambdas. We can also leverage, for example, the lambdas layers. If you want to basically cache some like big dependency, we can take advantage of the lambda layer, for example. So this is basically, so dependencies actually keep the lambdas with a single purpose, right? I'm mentioning now the single responsibility purpose. So actually acting on events, actually it's important that we actually separate the lambda per purpose, right? If I want to send a welcome email after a user signs in our platform, I will just build a specific lambda for this, right? And this is the kind of thinking that I usually have. So keep it simple and try to decouple actually concerns and domains per lambda. And try to share as possible the same code. And if it makes sense, build a small monorepo. That's basically what I usually do. But we have.
I think that's a great tip. You utilize monorepo with lambdas and then deploy everything together.
But it's important that per domain, right? I will not mix up, for example, half domain with pricing domain. Doesn't make sense to be here because probably the authentication or the user's domain makes sense to be in its own domain because it's being used for other services connection. So I would use monorepo, yes, but with the responsibility, right? Let's keep it simple. Let's keep it per domain.
Makes total sense to me. Maybe let's end with a fun question. When would you not use serverless?
That's a tricky one, to be honest.
Because we use it for everything.
Yes. To be honest, for now, I would use it for everything, unless I have a real good reason to not use it. As I think I mentioned initially, that maybe for long-running processes, the serverless is not a good case. But probably I will start playing with serverless computing.
In most cases, you always start with it.
Yes, I will start with it. And we can, nowadays we have powerful functions as a service, right? It's not like as we had them like 10 years ago, right? Nowadays we have fair timeouts, actually, when combining
15 minutes now.
When combining with the AI and LLM API calls that we want to make, it's a bit slow and probably will face some timeout issues. But for most of the cases, we can end up with a Lambda with good memory that can actually run like a powerful logic there. And we always have tools that can make like the communication really awesome, like step functions. I can build complex workflows, even for AI, right? We can actually separate the, like, I don't know, imagine that we want to chain several LLM APIs calls. Maybe I can use step functions. So this step function will analyze the image. Then I would like to have some outputs from the LLM that I will use to actually build and then get a structure output or something. So we can chain several functions in one place. The lambdas are stateless. So using this kind of step functions can actually help us because we can have the state going through, you know.
And even for your example of having like a long-running process or like having something, a long-running action, I had to recently build for epilot a bulk messaging feature. It could be that you're sending a message, an SMS or email to 100 of your customers, or it could be, 500,000 customers. It depends on the size of our customer, right? And for something like that, right? Like traditionally, I guess, Lambda is not a great choice because you can run only 15 minutes. I think right now is the maximum time that a Lambda will run. But what I actually end up doing is using step functions because you can have recursion within step functions. So essentially, you just have a queue, and then the queue is getting processed by this Lambda, and every time you're running close to the limit of the Lambda, you just start a new Lambda execution, and then basically you have infinite processes.
We can parallelize as well tasks there.
Absolutely.
We can parallelize function, right? And
Absolutely.
you can retry specific steps on the workflow. It's amazing.
Yeah.
So
I think the only the famous case was recently, I think it was Prime Video, who were doing some sort of video processing on serverless initially. And then famously, they stepped out of step functions to do something non-serverless. And I think there are probably edge cases where it could be the costs that become too large for something like that, especially if you're handling huge amounts of data. That's maybe one of the weaknesses sometimes of Lambda and step functions, is that it's a little bit limited, how big the payloads are. You end up doing things like loading a lot of things from S3 to kind of just go around those constraints. But on the other hand, I think those constraints also, they produce simplicity in the end, because it gives limitations to the developer not to do crazy things like massive payloads being passed around different services.
Yes, and data processing is actually used in serverless computing, right? But it's the way how we want to architecture.
Right.
If I want to have a single piece of code that handles all the data there, okay, let's go for a long-running process. But
absolutely,
if I can split this in several pieces, maybe the serverless can be a good use case even for data processing, right?
Absolutely. Then, Alex, I think we're out of time. Thanks very much for your expertise here. Yeah. It's been a nice conversation, man.
Yeah, it was really nice. Thanks to you as well.
Cheers. All right.
Cheers.
You've been listening to the podcast for product engineers. Don't forget to subscribe and join us next time.